So now floating point numbers are numbers which is storing values like this, right? Or values like this. Yeah. So this is what you store, right? My question on this is, how do I store something on a register like this that has a dot? Letters, these are just this one has an ASCII value. I will talk about that later as well in this chapter, but I like to talk earlier because in that case you will have idea. This one is in the chapter 11 or 14. I mean, not the chapter, I mean the section 14, I guess. What is ASCII? ASCII is just a numerical number, represent these letters, and then you can convert this to actually zeros and ones like that. This is what actually storing this. So even in numbers, we can directly use these values, right? 7 is 111 actually. So we know how to store letters. We know how to store numbers. So how about numbers with dots? Something like this. How can I store a dot in this? Does anybody have an idea how are we going to do this? If you really want to talk about this a little more, let me go to that and come back. I think it's under constant variables, math functions. Let me go a little bit more integer division and modular. Okay, so I'll give you a few minutes to think about it. How are you really going to store a dot in a computer, if anybody knows about it? Anyone have any idea how are we really going to store this? Can you think of a way to store a dot in a computer? At least an idea. Give me an idea. How can I really going to do this? What do you think?
Can you just save the ASCII number for it?
Well, what about the dot? So that's the point. What about the dot? How can I handle the dot here? Let's say we're making a computer the first time in life. So you have to know, well, how can I do this? What are the options we have to store something like that? So the question is, yeah. So I like to get your input on this. How do I really going to do this? Any idea? How do I really going to put a dot in a computer? Right. So it's a good question, right? I mean, well, we are using computers, and we have only switches in there. In that case, how are they really going to put a number? So with the dot. So this is the architecture for that. So we're going to use, this is my register, right? And first bit is what is this bit for? I talked about that earlier. The first bit.
Sign?
Yes, it's a sign. Either it can be plus or minus, right? Yeah, so that is that, okay? And then the rest to follow. So what we do is we break the rest, this part right here. two pieces. Okay, two pieces. What are these two pieces? I'm going to put there. This is for the floating point numbers, like for example 7.5. I want to store this number in here. What I'm going to do is I'm going to write this as 75. I mean actually 0.75 multiplied by 10 to the power what? What is the value here? What is the value I should put here to write this in another form?
1.
1, yes. So in this case is 1, right? So in this case, whenever the floating point numbers, I will write it in this format. Okay? And then I will store this 1 in here. So it is 1, 0, 0, 0, 0. And so this one is we call exponent. Exponent. All right? And then this part right here, 75 will store here. Okay? So this is your 75. That means I think I have to divide this to 6 pieces, 7 pieces. Let's say I have that like that. So the 75 is actually 2 to the power 6 is 64, right? And how much I need? 9 more I need, right? Let's go down, and then I get 2 to the power 3, 1 that is 8, right? I mean, I need 11, and then 2 to the power of 1 is 2. So yeah, so 8 plus 2 is 10, and 2 to the power 0 is 11. So that's 75, right? Yeah, so this is 10, that is 74, plus 1 is 75. So I will have all the other zeros here. 2 to the power 5 is 0, 2 to the power 4 is 0. That is 1, 0, 0, 1, 1, 1. So this will give me what? This will give me 75. So it is 1 here, switch on, switch on, switch on, off, off, switch on, off, off. So this is what 75. So this means this part I'm going to store like this. And then the 10, I'm going to put it here. So in that case, you can take care of this numbers representation on the array or the register like that. And then this one is called mantissa, mantissa, right? Mantissa, right? So that's what it's called. Right, so the exponent and mantissa, and then the sign. So you're going to use that. So this is the important part is if you don't use any signs in your code, it's better you say unsigned. Why? If you're using unsigned values, you can get use of this bit also. This is a huge number representing because if it is going from 2 to the power 0 to whatever the number, this will be a really big number. Like for example, if I have 8 bits or whatever to represent this, 2 to the power 9 is a huge number, right? So if you allocate this one only for the sign, that means you cutting down your number size with a huge magnitude, right? Yeah, because this is the last one. When I come to count from 2 to the 1, 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, like that. If you count to this one, it would be a big one, right? So in that case, yeah, it's better that you're using a lower number. I mean, better that you're using this if you have a bigger numbers to operate in your system. So that's why when you're writing a program, you may have seen unsigned float or unsigned int in that manner. Why people using this? Then you can handle bigger numbers, right? So if you're never going to use the integer negative values or floating negative numbers, then it's better using unsigned. But if you're using negative values, yeah, it is not a good idea to have this because then you're never going to see the sign. For example, in your program, if you get to see out something like this, right? 50 minus 100. So if you define some variable called unsigned integer, and if you store this is actually a minus 50, right? Right. So in that case, if I'm going to store this in here, it's never going to happen because there's no sign bit available for this kind of a variable because it's unsigned int, right? So in that case, you'll be in trouble. So keep in mind, you may have seen programs with unsigned int, but unsigned and signed, the difference is a significant bit in the leftmost, and that carrying a 2 to the power a bigger number. In that case, you can store big numbers. But if you're using a signed, make sure you don't use unsigned. Okay, so I hope you understand what I'm saying here. Does anybody have unclear section on it? What did you understand? Okay, so I take it as you understand it. Okay, so right. So then let me go to the floating point numbers. The section I just showed you is at the late on this. I mean, later you can see that when we're moving on. If you're interested of reading it, please do right now. I mean, carry on reading and play around with it. You will learn by doing this yourself more than what I teach here. And then when you put it into practical sense and do the labs, you will understand this more. So for this week lab, I have assigned something to practice what you learned so far and try to do it by yourself without taking much help from the others. Yeah, of course, if you get stuck, get help. But I'm saying is, don't copy things. I have seen so many people doing one thing that people do mostly, even in industry, when you're writing a JavaScript program, they just go and find those on the internet and then copy and paste inside the code they're writing. So that's not a good practice if you do that. Picking up code samples and paste it in your program. Well, you're not come to that level yet because if you're writing very easy ones right now. But yeah, I just want to make you be aware of this idea. Don't do that. I mean, don't copy and paste code from internet and just. So why? Well, those having us too many overheads, which means unnecessary code that you're putting in there without without knowledge. It is not a good way. So when you're writing something, write purely, okay, and then yourself. Love yourself. Think this section as you improving your brain yourself. So that is a good way of a good mental condition when you're thinking like that. I mean, like improve. You love yourself and you want to improve yourself. Okay, so that gives you some more confidence when you are moving on, especially in programming. You should have your own confidence to write something, right? So practice yourself. Go through these chapters and then do the exercises. There's so many tons of exercises here. So you paid a lot of money to get the subscriptions. In that case, get use of it. Okay, play around and learn a little bit more. Okay, so saying that, so we came up to the just the how these are stored in the machine, and well, if you don't want to know about that, you just simply say, if I want to use something like that, I call it float, right? Yeah, so the float, and there's another one called double. Well, that is the bigger size of float actually. If you want to have more numbers after dot, like a bigger value here, right? That if you have a bigger number here, that dealing with the dot after dot a lot, then you're using a double. If you have just a smaller values like this, then you can use float. So that's the difference. If you get more precise values, like for example, I really want to get calculate something very important, then I will go and I mean, very important means accurate values. Like for example, I want to go more than 2 decimals here, right? And representing some bigger numbers as float. Then I choose this one, right? Especially on this part, which you just define as a float, you don't have much more control on this, right? But here you can have more values and to have the complex calculations here. So that is what this is why this is important. So yeah, but if you're using a small numbers, double is why you should not use double. Let me know. Tell me if you have an idea on it. Anyone?
Storage
Say it again.
takes up more storage.
Yes, it takes more storage, and it is unnecessary to have more storage. That's the one thing. The other thing is, okay, let me point out this. Have anybody heard this word, which is this? Has anybody heard flops? Anyone who did computer engineering, coding before? Nobody?
No, haven't heard
Okay.
it.
Right. So this is what called floating point operating per second, right? Floating point operations per second. So that's what this means. Okay. What that means is whenever you give a number to a computer, so anything like this, what does this do is you have to break this to this format, and then you store that in a register, right? And break into 2 pieces. And then whenever you're accessing this again, you have to convert back to this before you're using it with another number, right? So floating point operations are the heaviest program operatings that you have to do when you're writing a program, or the computer has to do, because it has a format. You have to convert it to format. You have to convert it back again. So back and forth it goes. This operation is the biggest operation in any machine, right? Okay, so because of that, there's no other operation which is going in the higher, I mean, takes more time than floating point operations. Because of that, the computer, the skills of a computer, right? Like for an engine, you call it horsepower, right? Yeah, like that, you can measure your computer speed or the ability of your machine processor by flops. So you may have heard the gigaflops, right? Megaflops, things like that. When it comes to the processors, right? How much flops is executed, right? So this is how you measure how good is your processor is, right? So when it comes to the operations is handling, if you can handle the floating point numbers very fast, that means you have a good processor. Yes, in the early days, we talk about this a lot, maybe not now. The GPU has that. So GPU means the graphic card processing unit. The ability of that today's, I think it is still on giga, not teraflops. I think there's a supercomputer, I mean like the very SLI system, which is you have 2 GPUs parallelly running, that can do teraflop. That means it's a huge number. Okay, so gigaflops and teraflops are the numbers that we are talking about these days when it comes to the ability of the CPU. So if you have flops, if you have a value of flops for the CPU, the higher the number is better, because of these operating systems can handle that, right? So that's the one thing. So when it comes to doubles here, yeah, it is a huge operation and it is too heavy for the computer. So when you're doing this, it will cut down the performance for sure. Okay, so that's why if you don't want to use too many numbers here, you're using floating point. But if you are having these kind of ones, like this, like this, double is a good way of going. Okay, right. So that is one thing to keep in mind. All right. So how do I use doubles? Well, this is right here. This is a sample program that you have some variables here. So then we calculating, and this one we calculating what we going to do. Well, yeah. So this is calculate how much hours to drive or fly and things like that. If you're given the values by this and then the speed, so how much long it will take. Like for example, what you're talking about here is we know the velocity v is equal to distance over time, right? So how much time it will take to travel somewhere by bus or by plane is you just multiply these two by t both sides. So it will take vt is d, right? This to this cancel out. And then the t is equal to d over v. Why? So I can multiply these two by this. This to this cancel out. So this is what this taking as the equation. So you take miles travel, right? And so that is the miles that you're going to travel. And then if you fly, it says 500 miles per hour you go. That is the velocity. And then you divide the distance by that, it will give you a time, right? And then again, hours to drive. Well, you're driving at 60 miles per hour, and then then you're just printing out that. So this is a division. So that is why if you're having a division, always not all the numbers, like for example, 3 divided by 2 always give you 1.5. So there's a point here, right? So if I'm having only the integers, so this is actually integers, then should give you 1, right? If you have 3.0 divided by 2.0, this will give you 1.5. So that's the difference. If you turn, if you're having only integer format, right, you get the integer value. But if you're having it in the float format, you get a float value. Right, how do I know these are float or integers? Well, usually you can define things with a dot and then 0, or you can define the variables here with the same idea, okay? Right. So only thing, the float and doubles take more space than floats, okay? Right, so I think you have a clear idea about that. Let's move on. I'll go through these questions and answers. It helps you to develop your knowledge. I like you to spend a little time on this and then learn by yourself, right? Which statement best declaration of initialization in a double variable? Well, you can say double and the name. And then, yeah, this is a good one, which is showing as a floating point. This one defined as an integer value, just store it in there, it's not good. Or this one doesn't mean anything when it comes to the variable. So it is this, the answer, it has to be. Which statement best assign the variable, both variable types? Yeah, obviously this one, right? Which you have a floating point. But if you don't want to use the floating point, yeah, you can go with this. I think this is what doubled. If the type is doubled, you should put it like this. Yeah, so play around with it. And yeah, so one practice they're pointing out here is if you writing numbers, like for example, even in coding, these both are right, but put a 0 at the front. Makes sense. You just put some values here. Otherwise, you're mistaken this to this, like that. So this one, this topic, this part right here is talking about in the beginning of, I think it is on the previous chapter, yes, up to here. Yeah, right here. This is talking about it here, right here. It says, yeah, you it might confuse you if you don't put a number in the front of it, front of the dot, okay? So it says here. So it's a good practice that you put a value in the front of it, like 0.5 instead of just a .5, okay? All right. So that's what they're talking about here. So this is the good way of doing it. All right, so play around with it. And yeah, this is another important part, which is whenever you divide something, I talked about this earlier. So let's say you have a float, A is a number, float B is a number, and then I need the answer, float answer, right? Answer equals A divided by B, right? So, and then I take the answer. So the problem here is there's a potential, this one can be a 0, right? If this one is 0, what happened to this, right? For example, 5 divided by 0, what is this? It's not defined, right? It's an infinity, or it's not defined, right? Because what? 0s to 5, how much it is. So sometimes the machine handling this is as an AND, which is not a number, right? Or it is indicated by infinity, like this, right? So when you're writing a program, mostly this can happen, right here. So it's better you be careful on this. Usually, when you're writing something like this, you will have if statement. If statements we're talking about in chapter 3, when we come to that. So usually you say if the B is not equal to 0. Okay, so this is not equal to 0. Something new that you will learn later, if else, right? But if you don't want to go that. Yeah, so this is the best way of defining this, then AB, right? If this is 0, there's no reason you won't get an answer here, okay? This will go somewhere else. I mean, these are the returning values. It's not good. So it's better whenever you're dividing one number by another, it's better that you will handle it, protect it by if statement, okay? Keep that in mind. You will use this later. Yeah, even you don't use it doesn't mean that your program is not running. The program will run. There's no doubt of it. So the only problem here is even the program runs, whenever it hits 0, you'll get wrong answer, right? So that means your program is not accurate. There are incidents that can happen. So it is a good practice. You keep, you be aware of these things. Okay, so be aware. If a number divided by another number, if that number is 0, your answer is wrong. Okay, so you have to check those facts, especially when it comes to this. There's no rule or anything out there to prevent this. I mean, when you're writing a code, if you don't have this line right here, your program will run. But the problem is, whenever I hit this situation, you get a wrong answer. Okay, so the quality of your program depends on that. Okay, so those are the things that you have to be really careful when you're writing a program, because not the compiler going to check that and tell you, hey, you're dividing a number by another. It's not going to tell you like that. The system is not intelligent enough to give you output like that. Even in Android, the smartphone coding, it is not there. So yeah, so be aware of those things. It's very important. I'm just pointing out this because when you go to become a bigger programmer, like developing a lot of heavyweight programs, those kind of simple mistakes can do a lot of damage to your code. Okay, right. I hope you understand that. And right, so manipulating the precision, we're talking about this in this week lab, I think, as I remember, set precision. So that means, well, if I'm printing out a floating number, if I'm printing out a floating number, like for example, I have 5.7898, right? I don't want these two numbers to be there. I just want to be simply $1.78, right? So if I'm talking about currency, I don't go beyond this point, right? You always stick with this. So if I want to point out only the currency here, or something like that, then the precision 2, which is a set precision. So that means if I have this as my input output value, but I just want to point it as a 5.72, in that case, I can say set precision and then the variable name. So in that case, it will show you like this. Otherwise, if you don't have this, this line without these two, right? In that case, you will have this big number right here, okay? So that is a set precision, how you want to output things, okay? And you can output things using that. So that is what they're talking about here as a set precision, right? So let's move on. Yeah, these are things I would ask you in the test as well. If I want to print just a 2-digit number, how do I do that? So make sure you're using a set precision, okay? All right, those are little things. And the scientific notations, we went through this again earlier. Scientific notations in your calculator will give you these numbers with the e to the power. So what is this? What is this e to the power thing, right? Usually when it comes to the e to the power, you may have seen these numbers in your calculator for sure. I know e to the power 23. What this means is you get 6.02 multiplied by 10 to the power 23. So this is what actually the number is. And you define it in here. But these won't work in your program. Okay, so this is not something that you can do in the computer. Definitely E is not something that you can store in the computer. So it's always going to throw an error if you do that. So eventually, there's no way that I can put E in there. So keep that in mind. When you're writing this, obviously you have to write the whole number. Unfortunately, that's how it is. I never seen any language handling E. Have you ever encountered E? Anyone in a program? Python, JavaScript? I never encountered anything like that. Okay, so if you do, please let us know. If you do coding in other platforms, okay? Right, so this one is talking about that, how I'm handling these things with those numbers, right? And okay, so that chapter is about that, and then the constant variables. Okay, so in the constant variables, why is the constant? Why is it important to have a constant variable? It's just it is helpful for the programmer to handle things. Like for example, the things we're talking about here. So this is a new price. They're giving an example as a new price is a variable, right? There's no space here. Is equal to original price minus 5. Okay. Instead of saying -5 here, it's better you just say something like a discount or something like this, right? So just writing this as a word, if it is always 5 in there, if you're using a -5 for all the products or something like that, instead of you writing 555 everywhere, this makes sense, right? Using a discount price if it's a constant value. That means throughout the whole program, this won't change. For example, okay, I have a shop. I have some goods in my shop, right? I have apples. I have grapes. Let's say I have so many products to sell. And then these are there sitting there for a while, and it's going to go bad very soon. So you want to sell these faster. So what you do is I assign a discount, right? So then you're writing a program for that. In that case, I will decide how much discount I want to put here, right? So, so what I'm going to do, if I write a program, so apples, today I give you $5. And then for the grapes again, I give you $5, right? So like that, I'm writing for the whole list, 5, 5, 5, 5. So there's a lot of coding that you had to do, write this one forever. And tomorrow I come again, I could not sell for 5. Now I want to put $8 instead of 5, so discount 8. So in that case, I had to go through the whole list and edit this again, right? Like that. That takes a lot of time to do this. So it's easier if you write something the variable name, apples minus discount, right? And I'm defining this discount up here with the value, right? Equal 5. So in that case, you don't have to edit every time. So it's always the value, the variable name will be there. Even I come tomorrow. Only thing I had to change when I come tomorrow is this value right here, right? And it will remain for the whole program as the same. So, so it is a good practice using a constant value that you're not changing for the whole program itself, and it's will stick there. So this is where I'm using a constant value, const, right? So that is one use of things, especially when you're talking about pi, right? 3.14 something, right? So this is for rotations and arithmetic calculations, which is doing calculations of, especially in graphics, I use that a lot when I'm rotations, matrices that rotates and things like that, or you calculating rad values and things like that. Pi is very important, especially for the scientific calculations. So in that case, I just define this either constant. Right now you're learning constant, so it's a constant. You can say pi equals this, right? So it is a constant value that never changes. In programs, especially when it's come to constant values, we're using a caps locks like this. We say capital letters, right, to define it. And it will remain same for the rest of the program. It's never going to change. So why is it important? Well, yeah, instead of you writing this, this is a much better way of writing things. That's a good practice actually, right? So that's why using constant values. And that helps a lot in the long run. So yeah, if you having something which is not changing throughout your program, call it constant. It helps. So that is what they're talking about here in this chapter, right? So make sure you understand that. Math functions, we already use square root, I think. If you did not, maybe in the future you will. I introduced square root earlier. So that is a CMath. This is a library for using those things. We're talking about few of the math functions here. So at least 3 of them, right? So if you are not aware of it, please go through that. If you want to find the square root of 4, what is the square root of 4? Square root of 4?
2.
2 is that. Be more precise, it can be -2 or +2, right? Yeah. So what would this return in that case? That's an interesting question, right? But initially, this will return 2 actually, yes, 2.0. If you're using a float numbers. But actually there are two values here, right? Yeah. But in computer it's returning only one most of the time, okay? And the positive value, obviously. Yeah, so this is a, if I really want to calculate something, only the positive values, there's another function which is called fab. Like for example, if I have a fab's absolute value of this, it will return you only 9. So it cut off this value right here. So it is called absolute value. So in a computer, using a function fab for that, okay? So that keep in mind. If you want to find the square root, it will return by this value. Simply to return the positive value, positive for portion. And if you have negative values, if you want to convert it to positive only, so you can use this one right here. Right, and then the other one is this, 2 to the power 2, 2 to the power 4, things like that. You can use something called POW, right? And then the first part here is the value that you want to use. And this part is the exponent part, which is the power, which is this one most here. This one is here, right? So X and Y values. So that is what this. These three are most commonly used math functions. Of course, there are trigonometry, sine, cosine. If you want to use those, CMath helps. CMath is the library, which is we're showing right here, CMath. Okay. So if you have CMath, and then if you want to calculate that, obviously you can. Okay. Right. So keep that in mind. Go through this by yourself. Don't want to spend time on this. It says a square root equal to what? Well, obviously it is 6. That is what it is. And then what is the square root of 81? It's 99, right? I mean 9. And what is this gives you? 2 to the power 8. What is 2 to the power 8? It's weird like this, right? It is not 8 to the power 2, it is 2 to the power 8, 256. Is this works? No, because they have two numbers under square root, so it is not going to work for you. And is this a valid function call? No, you don't have the power there. It's just a number. It won't work for you. And if W and X are double variables, is this a valid function? If you have doesn't have any values there. If you don't have the values, this is a problem. But otherwise, yes, it is the right value. And what is y in this one? Well, you can write it like this as well. It's pretty good. You have w is 3, and w is 3 plus 1 is 4 to the power 2 is 16. It has to give you 16. Yeah. So those are things. Yeah, play around with this. It's just the growth rate. Yeah, so one question here. It's an interesting question. Let me ask that just to bring you back from your monkey minds is running everywhere. You get bored with my voice only, right? Okay, so let's say a good one. Okay, so do you know chess? Anyone playing chess? Nobody play chess?
No, the basic.
Yeah, I play.
Oh, the basic. Okay, so this happens when whenever whoever introduced this chess, the game of chess, he went to the king and introduced chess, and the king was impressed. Okay, this is pretty cool. So what should I give you as a present in order to tribute that what you did? Okay, and then this person, whoever introduced chess, he said, okay, so this is a chessboard. How many rows and columns it has?
6 rows, 6 columns.
Well, it has to be 8 by 8. Okay.
Oh, 8 by 8.
Yes. So 8 by 8. So what he said is, okay, put a 1 grain of piece of grain here. And for the second square, put 2 grains. For the third square, put 4 grains. Like that, double the amount of grains that you have here to here to here, like that, right? And he said, okay, so and then fill the whole 64 squares in there and give me that much. So that's what he said. Okay, so the king laughed and said, oh, that is a very small price that you're asking for, right? But what happened here is, when it comes to somewhere in the middle, it will come to 1 bag of grains, and then next one it will be 2 bags of grains, and so very quickly it will fill up to a lot of bags of grains, and then you will have the whole store of grains, and then 2 stores of grains, and so on. It will grow rapidly. This is 2 to the power 64, right? That is a big number actually. This number of grains is the huge number that you cannot even imagine that you have enough, right? So after a week, when the king came and asked, did you give him the price he named for? And then the soldier said, we don't have that many grains even in the whole country. So that's what happened. I mean, this is a pretty interesting way of thinking this. What is the point here is, if I have a small square, and if I want double the size for the next one, and double the size of that one, right? This is not, if I have x here, this is not 2x and 4x. If I say I'm multiplying by 2, that is not right, right? When you double something by double of its own, it's always 2 to the power. I mean, x to the power 2, right? And then this one is x to the power 2 by another 2, like that. So it's always squaring itself or doubling itself. So in that concept, this power is very important. This one is talking about that. So if you go through this sample right here, okay, what I want to point out is when you say the growth rate, it is not just you multiplying a value with the growth rate. For example, here you're talking about the mass of a tree or something like that. Yeah, the final mass you calculate. So this is what the calculation is. So you pick the first value, the growth rate on that, and then you power it by the year. So each year it will be grow by the power of it. That means it's bigger this much first time, and then next time it will grow out of this height, right? For example, let me recall this again. If you have one size right now, out of this growth rate is 0.5, let's say, right? And for the second time, the growth rate is actually depending on the height. So that means, let's put a value here, right? For example, 2 to the power 0.3. So this is what the first year growth rate, right? And for the second year growth rate, if I multiply again this value, so you have to calculate, multiply this by another this, right? So now it is a square of that value. For the third one, I'm going to calculate this much multiplied by this much. So this is the height and multiply by this much. So this means it's always power it up, not a multiplication. So this is what I want to point out. In that case, you're using a power. So this is the example of using a power repeatedly for one thing. So that is same as the chessboard story, that you will double the value each time. And here also we're using the original value. That's, it's not the initial value, it is changes. So each time when you're talking about it, you have to power it up, right, by the same value. So that is the point that I want to say. Repeatedly, you power it up. So keep this in mind, especially in a logic error. So many people do the logic error by just multiplying the values instead of powering it up. You know, there's a significant difference between the power things or the multiplication. So this is one of the examples that they're using the power for each year, because the original value will change because of that you have to power it up. Okay, right. I'm not sure whether you understand that. When you come to the practical sense of it, you will. Okay, right. Well, the rest of it is just how you calculate this. I talk about the precedence, which means if you have multiplications and pluses, you always do the multiplication first, unless you have brackets. So that is one thing that you have to keep in mind. These are math functions to play around. So go through that again, and you'll be good. All right. So what did you learn here? Well, I talk about power. I talk about square root. I talk about fabs, 3 mathematics functions. Okay. And so the integer divisions and modulo. Here, again, I talked about this earlier. When you're having integer divisions, one thing that you have to keep in mind is if you have integer value A and integer value B, and your answer also integer answer. In this case, what happens is if I say answer is equal to A divided by B, and this always gives you a constant value. I mean the integer value. For example, if I have this one as 4 and this one has 2, let's say, right? 2, no, 3. This one is 3 and this one is 2, let's say like that, right? Again, your answer has to be 1.5. But if your answer is integer, this will equal to only 1. Okay. Right? So if you have 3, 2, and then A divided by B will give you 1 as the answer if you're using integers. Right? So keep that in mind. If you're using those kinds, if you want to accept accurate value, of course you have to use this. But there are some events that you're just using the integer value instead of this. There are some. One example I gave you last time was on this is, what is it? Finding a specific number digit in here. Right? If I want to find 7 in this number, I ask how you do it, right? So how you do it is I can define value 10, right? So let's say this is the division is 10, and you put this number in A. Okay, so you're using 2 things here. One is I'm using a modulus value. Right now I don't have anything. One thing I can do is I first take you divide this by this 10 and put it in A. Okay, so that's the first thing you do. That means what? I get A as 57. And the second thing, before you divide this, what you do is you calculate the mod, right? You calculate the mod of 575. Mod means this one, the modulo. That's what we're talking about here, and 10. So what does modulo give you? Or the modulus, you call it? What is that gives you? Number modulus 10, what is it gives you? Anyone?
Is it the remainder?
Say it again?
It gives you 5.
Yeah, it will give you 5. What is 5? What is 5?
The remainder.
Remainder, yeah. So it's giving you the remainder, right? So the modulus, this means you get 5 here. and you say, so I want to find this 7, right? So what you have to do here is so it is if condition, if whatever the value here, so if mod equals 7, you good, then you don't have to proceed, right? Else you do what you do this part, right, which is you divide the number by 10, and if these are integers, obviously you get 57. So that's the good part. This is the example of you using this is the example that you're using the integer division instead of a float division. Okay, so in that case I get 57, and then again I will do the same whole process in this case. Actually, this one is A here, right? So whole process again to find the next. So then right now the A is replaced by 57, and 57 modulo 10 is what? 57 modulus 8, 10. What do you get?
7.
7, right? So in that case, yeah, it comes here. Now this one replaced by 7. And is 7 equals 7? Yes. In that case, it won't go to the else part and to quit here as a return true. In that case, yeah. So that means you're good. Okay. So that means the 7 is inside this number. So this is just to find the number inside the series of numbers. So this is a process that you're doing with a loop as well as integer division, just to find the number inside the number. So that's a pretty good way of thinking when it comes to the numbers. Okay, and finding a number digit inside the number. Okay. Yeah, so integer is always giving you a rounding. So that's what I just showed you. And if you're using a float numbers, obviously it will give you the decimal value right here, 0.5, whatever. So that is what they're talking about here. Well, go through this. I don't want to spend time on it because it's always there. And then so it showed the answer. If you double click on this twice, it will give you the answers. So play around with it. First, you answer yourself and see whether the answer is correct. Okay. Again, division by 0, same thing. Be careful on that. That is also talking about here on and on. One thing I want to point out about the modulo handles only in integers. If you're using a float numbers and try to calculate modulo, it won't give you that. Okay. So you always have to have integers in order to do the modulo operator, right? So the modulus or the modulo is nothing but giving you the remainder. Okay, so you know that already. And the importance of this is whatever you have in there, calculate that. I think why the parenthesis matters. Obviously, in this case, you have parentheses, whatever inside that will be the first operation in this, and then carry on to the rest. So that is very important, having parentheses to calculate things. Okay, this is a modulo examples. We will come to this a lot. Okay, so let me talk about random numbers. They're talking about here random numbers. It's pretty interesting too. Random give you a random number. Like for example, this rand function, you will learn later on. If you call rand, this will return any value. Like for example, 1 or next time when I run this, I can have 100,000, right? And next time 50, next time 97, so on. Okay, one thing I want to point out here is very important. If you go to the higher level of education, like do the research and things like that, I want to point out one thing. There's no such a thing called rand exist in programming. Do you know why rand is not actually a random number? Any ideas? Rand is not a random number. What does that mean?
It's pseudo-random.
Yeah, I mean, why is it not a random number? What is random means? Random means there cannot be any sequence of generating anything like that, right? So it is random. Like, for example, if you throw a dice, it can be any number, right? Yeah. But if I really want to generate a random number, you should not have a sequence, right? Saying, okay, this is a number I'm generating by doing something. But can you really write an algorithm or think of a way to generate a random number? That means, okay, I'm saying, all right, go and find a number 5 and then divide by another 5, add 1, or multiply by 100, get a number. And then whatever the number I get here, which is 102, use that number for the next time and then do something else and then get another number. And use this number and do something else and get another number. So like that, I can go on and maybe using a modulus values and things like that. But all these have a sequence, right? Yeah. So these are instructions and those are static instructions. So whatever the time you run this program, it's always give you the same number. Especially when you're running this RAND in 2 machines, both machines will give the same number output. Maybe it will give you 10 first time, second time 20. In computer A, it will be like that. Computer B, it will be like that. Computer C, it will be like that, right? This is a good way of thinking. I will stop here and yeah, think about this. How do you really going to generate a random number? Is there a way that you can come up with the idea to generate a random number? Why I'm asking from you? Because up to now, the people are still doing experiments on this. Actually, how are you really going to generate a random number? Think about this. If you really want to get, I like to see whether your fresh minds, not thinking this much before, may come up with a good idea, right? Be a little bit creative. So if you really like this topic, see whether you can come up with an idea to generate a random number, because there are no such a thing up to now. Especially using a rand function, you can run a program testing if you want. If you run rand and output the value, it will give you the same value in 2 machines or 3 machines when you run it. That's not the case. It should give you a random number, means it has to be a random number in every machine, right? There's another SRAND and things like that, which is involving some other stuff to do this. Okay, so think about this and see if we can come up with something. So I will stop here and continue on Thursday and finish chapter 2, and then we will move into